Hello, my Calc 2 student. Today we covered section 8.8, improper integrals. Okay. If our function, first I give its definition. Okay. I don't know, 8.8. If we have function f who is continuous for giving all interval integration, and then we have a. If we have integral from a to infinity fx dx, we need understood this one like limit b approached infinity integral from a to b fx dx. This means we need to integrate and then found limit. What happened with your function, antiderivative function, if argument approached infinity. B, if you have integral from negative infinity to b, function fx dx, it means we have limit a approached negative infinity, integral from a to b fx dx. And last one, C, if you have integral from negative infinity to positive infinity fx dx, you can take at any point C and rewrite this integral like two integrals from negative infinity to c fx dx plus integral from c to positive infinity fx dx. How work with each? This integral, we know if we use definition a and b. Okay, looking some example. Example 1. If I have integral from 0 to infinity e to the negative x dx. This means this integral is, if it's our definition, we have limit b approach to infinity, integral from 0 to b e to the negative x dx. This integral is very good. This means we can integrate now. It will be minus e to the negative x from 0 to b. Here's the limit b approach to infinity. Okay. If we plug, we have limit minus 1 over e to the power b, where is b approach to infinity. And if you plug in 0, you have negative 1, but because you need subtract, you have plus 1. Okay, this fraction is approach to 0. This means your integral equal 1. See more examples. Example 2. Integral from 0 to infinity dx over x squared plus 1. It means limit integral from 0 to b approach to infinity dx over x squared plus 1. We remember this is arctangent. This means the result will be limit arctangent b approach to infinity minus arctan 0. Arctan 0 is 0. This means here we have arctangent b, b approach to infinity, is will be exactly pi over 2. Looking one more type of improper integral. Improper integral with infinity discontinuous. This means it happened if you have function fx, first example, continue on integral a, b, but b is not included. And in point B we have infinity is discontinuous. This means function fx approach to fx approach to infinity if x approach to b. Then our integral from a to b fx dx will be limit integrals from a to c fx dx, but here is c approach to b to the left. Second situation, if fx is continuous on open interval AB, whereas A is open point. And we have same problem here. This means fx approach to infinity if x approach to A. Here we have integral from A to B fx dx. It will be limit integral from C to B fx dx, but C approach to A to the right. And third situation, if fx is continue and close interval AB except some inside point C. This means point C is not equal A, not equal B, it's something inside our interval. Then integral A from A to B fx dx will separate for two integrals from A to C fx dx plus from C to B fx dx. And how work with each of them integrals? You know, because first is from our first definition and second definition. Okay, good. Looking some example we can solve. For example, example number 1, we have integral from 0 to 1 dx over cube root from x. Remember what does mean we need found define integral. Okay, we need found some area. Let's go here as 1 and 1, and this means we need found this area. But this trapezoid is not finished, it's go to infinity here. Okay, what will be area here? We need count. Bad point here is 0, because if you plug in 0, your function is not exist. It is continue but never take it. Okay, what we have here? We have limit A approach to 0 to the right, integral from A to 1 dx over cube root x. Here we can integrate. X the power here is negative 1/3. Add 1 as will be 2/3. This means I have a limit x to the 2/3 over 2/3, and I need plugging a and 1, and a need be approached to 0 plus. Okay, great. This means 3 halves. If you plug in 1, you have 1. If you plug in 0, you have exactly 0. This means here is 3 halves. One more example, second one. We have integral from 0 to 2 dx over x cubed. Limit a approach to 0 plus integral from a to 2 dx over x cubed. If you plug here, you have limit a approach to 0 plus. Here you have x to the negative 2 power over negative 2, a 2. Plugging, if I plug 2, I have limit a approach to 0 plus. I have minus 1/8, and here I have plus 1 over 2a square. But if a approach to 0, you have infinity here, and this integral is diverges. And for third situation, we look in some integrals from negative 1 to 2 dx over x cubed. We now, from point between negative 1 and 2, our function is not continuous. We have this connection point c equals 0, which is from our interval negative 1 to. This means this integral will be from negative 1 to 0 dx over x cubed plus from 0 to 2 dx over x cubed. And because example number 2 show us this is integral diverges, this means some two integrals will be diverges too. This is diverges. Then a couple of examples from your book. Number 24, for example. Here you have integral from 0 to infinity e to the negative x cosine x dx. You have exponential function times trigonometrical function. This means we need to use integration by part 2 times. And first, do it separately. Found function e exponent x cosine x dx. Integrate by part. Let's go. E exponent negative x will be u. Cosine x dx, it will be dv. This means du is minus exponent x dx, and v it will be sine x. Okay, here we have uv e exponent minus x sine x minus v du, but remember we have minus there. This means plus integral e to the negative x sine x dx. Use integration by part one more time. E to the negative x will be u sine x dx. It will be dv. du is minus e to the minus x dx. And v, it will be negative cosine x. We have e to the negative x sine x. Vu, it's minus e to the negative x cosine x. And minus v du. This mean is, and here we have 2 minus, this mean minus e to the negative x cosine x dx. We come with same integral, and this means our integral equal e to the negative x sine x minus e to the negative x cosine x minus same integral. I don't write plus c here because we have defined integral and then we plugging. And now I'm only prepare my function, what kind of function I need. This means here I have e to the negative x half sine x minus cosine x. Okay, go back with our integrals. How you remember? It is integral from 0 to infinity e to the negative x cosine x dx. Because we have 1 as our border is infinity, this means we substitute b approach to infinity, integral from 0 to b e to the negative x cosine dx. And now we use what we counting. It will be plugging here b, limit b approach to infinity. We have e to the negative b over 2 sine b minus cosine b. And if you plug in 0 here, we have minus 1 half times 0 minus 1. Okay, now we start counting this limit. Limit, I will write this way, sine b minus cosine b. Here is 2 times e to the power b. b approach to infinity. Okay, and plus 1 half. What we know about this fraction inside limit? We don't know what this will be limit sine b if b approach to infinity or limit cosine b if b approach to infinity. But we know its combination will be always less than 2 because sine b less than 1, cosine b less than 1. This means sum or different is at least less than 2. We can prove something because it's never be same time each of them is will be 1. This means we can prove something more strong, but we don't need 2 is enough. This means this limit it will be something limit 2 over 2 e to the power b. b approach to infinity. Its mean is 0 because denominator is infinity and numerical is some constant. And finally our answer is 1 half. This means our integral is 1 half. Okay, see more interesting examples. For example, number 26. Number 26, and from your book, it will be integral from 1 to infinity, natural logarithm x over x dx. Well, I think it's One substitution here is natural logarithm x like t, then dx over x, it will be dt, and your integral, simple, we substitute t to the dt, but now we need counting new border. If x equal 1, natural logarithm 1 is 0, this means lower border is 0. If x equal infinity, natural logarithm infinity, this means for us approach, it stay infinity. Here we have a limit, integral from 0 to b approach to infinity, t dt, it will be t square over 2, this means here we have limit b square over 2 minus 0, and b approach to infinity. It will be infinity, this means your integral is diverges. Number 46. It will be integral from 4 to infinity x squared minus 16 over x squared dx. Well, how you know, we use trigonometrical substitution for this kind of integral, and try doing what you have here. X, because inside root we have function minus constant, this means we use substitution with secant, and x will be 4 secant theta. This means dx is 4 secant theta tangent theta d theta. Plug, we have integral inside root 16 secant square minus 16, it gives us 4 tangent theta. Dx gives us 4 secant theta tangent theta, theta, and denominator it will be 16 secant square theta. But now we need a very important counting border. Okay, x equal 4. What do you have? 4 equal 4 secant theta. This means secant theta equal 1 and theta equal 0. Lower border is 0. What happened if you have infinity? 4 secant theta equal infinity. This means secant theta equal infinity, and theta equal pi over 2, because secant is go to infinity if theta go to pi over 2. Okay, great. Here we have pi over 2. You see, now we have clear here. We have integral, whereas border is from 0 to pi over 2. Great. Simplify a little bit. 4 and 16 square and whole secant. And we have integral from 0 to pi over 2. Tangent square theta divided by secant theta d theta. Or it will be integral from 0 to pi over 2. Tangent square, it will be sine square theta over cosine square theta. Divided by secant, this means multiplied by cosine. Okay, simplify here. And remember trigonometrical identity, 0 pi over 2. Here sine square is 1 minus cosine square theta over cosine theta d theta. Separate for two fractions, and you have 0 to pi over 2 secant theta minus cosine theta d theta. And now we can see we have bed point pi over 2 for function secant. Okay. Here I have natural log secant theta tangent theta 0 pi over 2 and minus cosine theta. Sorry, I automatically make mistake. And mean this will be minus sine theta from 0 to pi over 2. Our logarithmic function is not exist for pi over 2. This means we need checking limit b approach the pi over 2 secant b plus tangent b. All others no problem. We have minus ln 1 sine pi over 2 minus sine pi over 2 and plus sine 0 who is 0. Okay, here we have secant b. If b approach the pi over 2, you have, this is ln. It will be infinity, tangent give us infinity. This means we have natural log from infinity, it will be infinity. And this integral is diverges. Now I'm solving two examples. It's very important. In future we use it's like formula. It's two example is 49 and 50 from your book. Number 50, you have integral from 0 to 1, 1 over x to the power p dx. Okay. Here we have, and question is where this integral is converges, for which p is converges, for which p is diverges. I'm working like formally. I'm all right. 0, 1 x to the minus p power dx. It will be x to the 1 minus p over 1 minus p from 0 to 1. What we have here, if x power is positive now, this means we can plug in 1 in 0. And we have answer is will be 1 over 1 minus p if 1 minus p is positive. And if 1 minus p is negative, this means x with this power go to denominator. You cannot divide by 0. You have diverges situation is diverges if 1 minus p is negative. Okay, maybe we rewrite one more time. This means our answer 1 over 1 minus p if p lower than 1, this means 1 greater than p, and diverges if p greater than 1. Situation whereas p exactly equal 1. Okay, checking what happened. If you have p equal 1, this means dx over x from 0 to 1. We have natural log x from 0 to 1. Then you have diverges, because logarithmic function for something approach to 0, it will be negative infinity. This means whereas diverges, we plug in equal here. Okay. Number 50. This we're doing 50, so sorry. Number 49, this we're doing 50. All right, this is 50. Number 49, we have, looks like we have same function, dx over x to the power p. Power, it's a little bit longer than you need. Okay, power p dx, but interval integration is different from 1 to infinity. This means problem point is upper bound. Okay, solving doing same. This means x 1 minus p over 1 minus p. Here we have different situation. This means if 1 minus p stay negative, x go to denominator, and you have divide by infinities will be 0 and solving correctly. And you have minus 1 over 1 minus p if 1 minus p negative. And you have diverges if 1 minus p positive. Okay, write one more time. Maybe this minus we put inside, and we have 1 over p minus 1 if p greater than 1, and diverges if p lower than 1. Okay, see our situation if p equal 1. What we have? Integral from 1 to infinity dx over x. It will be natural logarithm x. It's 1 to infinity. It will be infinity is diverges. This means where is it? We plug in here. Okay, this is 2 example. Please remember, because we use in the future when we start study our series. Okay, that's it.